In this video, we are going to learn about how to use molar mass as a conversion factor in our stoichiometry. This is part of our learning objective for applying stoichiometric relationships to calculate the amounts of substances involved in a chemical reaction. So we know that this balanced chemical equation tells us the molar ratio in which things react. And we know that all these different substances have different masses, and that the molar mass relates the mass of a compound to the molar amount. So if we're given a mass to start with, then we're going to need to convert that mass into moles using the molar mass of that substance. Then we can use that stoichiometric factor, also known as a molar ratio, in order to relate the moles of the different substances. And then we can get out of moles into the mass of the new substance using the molar mass of the new substance. Let's see how this looks in a real problem. So here's an example. It says how many grams of SO2, so we're asked to find grams of SO2 will form if 56.20 grams of H2S react, given 56.20 grams of H2S. So I identified where I'm starting and where I'm ending on this balanced chemical equation using these labels down here to remind myself that these are different substances, and so I'm going to need to get into moles so that I can compare the two. So I'm going to go from 56.20 grams of H2S. It's really important to label which compound you're in to help you remember. I need to cancel out my grams, and I need to get into moles. And this will still be in of H2S. And so this is where the molar mass comes in. So this is going to be the molar mass. That's going to help me get into moles, because that's always what my goal is initially for stoichiometry. Now I have 34.08 grams of H2S. Whenever I use molar mass as a conversion factor, that is a 1. Now I use my molar ratio. I need to cancel out my moles of H2S, and I need to get into moles of my new compound. That is a 2 coefficient in front of the moles of H2S and in front of the moles of SO2. They're both 2's. Now I need to get out of moles. So I got into moles, I found my moles of the substance I'm looking for, and now I need to get out of moles. I'm asked to find grams. So I need to cancel out moles and get into grams. Molar mass has units of grams per mole, and so that's going to help me get out. And so now I can type this all into my calculator. This is of SO2. All right, so we have 56.20 times 1 . Okay, let's start over. 56.20 times, try that again. Alright, so I'm just typing this into my calculator. Making sure it matches what's on my paper. And so this is going to be equal to 105.655 grams of SO2. I need 1, 2, 3, 4 sig figs. So 1, 2, 3, 4 sig figs. And so I'm going to keep the retained digit as a 6 so that it's even. And so I'll report my answer as 105.6. Here's a practice problem for you. How many grams of O2 are needed to consume 56.20 grams of H2S according to the reaction? Go ahead and pause the video and try to work this out, and then unpause the video when you're ready to check your work. Alright, so let's go over this. We are given 56 grams of H2S, and then we're asked to find grams of O2. So I'm going to need to get into moles to the other substance, and then out of moles. Whenever I'm trying to go from grams to moles, I'm going to be using the molar mass. So I'm going to start my math way over here. 56.20 grams of H2S. I need to cancel out my grams of H2S. I need to get into moles of H2S. And so that's going to be my 34.08. Then I use my molar ratio. That was my molar mass. Now I'm ready for my molar ratio. Now that I'm in moles, I need to cancel out 2 moles of H2S. And I need to get into 3 moles of O2. Now my unit is moles of O2. So I need to cancel out moles of O2, and I need to get out of moles. I need to get out of moles into grams. So now I need to use my molar mass to get out of moles. So that's going to be a 1 next to the moles, and then that's going to be 32.00 grams of O2. So that is 56.20 divided by 34.08 times 3 divided by 2 times 32. And so that is 79.15 grams. So the answer is none of the above.